Hi, it's Tim from ORACLE-BASE.com. In this video we'll give a quick demonstration of using the SQL Quarantine feature of Oracle Database 19c. In a previous video we discussed Runaway query management. Cancelling a runaway query is helpful to prevent wasting system resources, but if that problem query is run repeatedly, it can still result in a considerable amount of wasted resources. SQL Quarantine solves this problem by quarantining cancelled SQL statements so they can't be run multiple times. This feature is currently restricted to Enterprise Edition on engineered systems like Exadata and Exadata Cloud Service. SQL Quarantine is available by default, so we don't have to do anything special to start using it. A normal resource plan for runaway query management will trigger it. We'll demonstrate this by using the example we used in the runaway query management video. I'm not going to repeat the setup, so I recommend going back to that video for the setup. We connect to the test user. We need an SQL statement that will use a lot of CPU, so we create a function called burn CPU. This accepts a parameter that indicates how many minutes it should use CPU for. It then loops for that number of minutes, performing a simple mathematical operation. We could use some PLSQL to call the function, but instead we'll use the function call in a query, telling us to burn CPU for 5 minutes. After approximately 60 seconds we see an error telling us the active time limit was exceeded. The documentation would have you believe the cancelled call is instantly quarantined, but in reality it can take a long time for it to be noticed. In some cases I waited for over 15 minutes before the cancelled statement was quarantined. If you wait long enough, subsequent attempts to run a statement with the same execution plan will result in a quarantine message. The $SQL view includes the SQL Quarantine and avoided executions columns. We see two entries for the SQL ID, one showing the number of avoided executions as 0 and one showing it as 1. The DBA SQL Quarantine view shows us details of the SQL Quarantine definitions. This includes the threshold that was broken to cause the query to be cancelled and therefore quarantined in the first place. In this case it was 60 seconds on CPU. Since we're only looking at CPU time for this example, we'll just display this information from now on. The DBMS SQLQ package provides an API to manage SQL Quarantine. We can manually quarantine a statement based on SQL ID or SQL text. Both methods accept a plan hash value parameter, which allows us to quarantine a single execution plan. If this is not specified, all execution plans for the statement are quarantined. In this example, we'll use the create quarantine by SQL text function to manually quarantine all execution plans for a statement. The function returns the quarantine name. We now have two separate quarantine definitions. The original one for a specific execution plan and a new one for all execution plans. Manually created quarantines have all thresholds set to always. The alter quarantine procedure allows us to alter the thresholds to make them look more like automatically generated quarantines. The procedure can alter these parameters. We'll just set the CPU time. We set the quarantine name, parameter name of CPU time, and the parameter value of 60 seconds. We can see the threshold has changed to 60 seconds. The drop quarantine procedure allows us to remove any quarantine definitions. If we need to, the DBMS SQLQ package allows us to transfer SQL Quarantine definitions between databases. If you're interested in that, check out the linked article. So not only can we cancel problem queries, but on engineered systems in Oracle 19c Onward, we can quarantine them so they are not able to waste any resources if they're run repeatedly. Thanks for watching. As always, there are links to articles containing lots more information about this subject in the description box below.